All right, so we're going to continue with assignment number 4, talking about exponents. And today we're going to be multiplying exponents with like bases. So this is going to be a big topic. We're going to use it a lot from now until really the end of the year. So let's go ahead and get started here. Let's start with number 1. There's going to be 9 total problems that we're going to be doing through this video. So a lot of notes to take. But we have x squared. Now x squared means x times x. We're going to multiply x times x to the 4th, which is x times x times x times x. And so we're multiplying 6 x's together. Well, that's the same thing as x to the 6th. So what that means is, if we look at this in a shorter way, what did I really do with my two exponents? I just added them. If I have like bases, x times x, but I have different exponents, I'm adding the two exponents together to get x to the 6th. And so let's see how that applies to different problems. If I have n to the 5th, that's 5 n's, 1, 2, 3, 4, 5 that I'm multiplying all together. And then I'm going to multiply that by 3 more n's that I'm multiplying together. So all together I have 8 n's I'm multiplying together. That's n to the 8th. And again, a shorter way of looking at this is, if I have the same bases and I'm multiplying, then I'm just going to add the exponents together. N to the 5th times n to the 3rd is n to the 8th. If we continue with this, here I have x squared, that's 2 x's, but I have n to the 4th, that's 4 n's. And so this one I can't really do anything more with because the bases are not the same. This is just going to be x to the 2nd times n to the 4th. I can't put those together because the bases are not the same. They're different. And so the only time I can multiply things together like this is when the bases are the same, both x's or both n's. Let's take a look at something like this. So this is the same thing as writing it as 3 times n squared times 5 times n to the 4th. Well, I can multiply the 3 times the 5, that's 15. And then n squared times n to the 4th is n to the 6th. And so my final answer here is going to be 15 n to the 6th. Let's keep going with this idea. So here we have a negative exponent. A couple ways I can think about this. The w to the 5th means I have 5 w's on top. W to the negative 3rd is the same thing as w to the 3rd on the bottom. Well, that's 3 w's on the bottom. Those cancel, and it's w to the 2nd. Another thing you can think about it as, I have a positive 5 and a negative 3. If I add them together, what do I get? Well, that's a positive 2. And so again, the same rule applies. W to the 5th times w to the negative 3rd. If I add them together, that's w squared. If I keep going here, let's take a look at this. There's a lot going on here. I'm multiplying all this stuff together. I can multiply the 4 and the 6 together. That gives me 24. I can also multiply the a to the 5th times the a to the 2nd because those are like bases. A to the 5th times a to the 2nd, well, that's a to the 7th because I'm adding the exponents together. And then b to the 2nd and b to the 3rd, that is b to the 5th because I have 2 b's here times 3 more b's here. And so that's a total of 5 b's. So my final answer is 24 a to the 7th times b to the 5th. So let's try number 7 here. Again, I could get rid of these parentheses here and just multiply everything together. I could put them in different orders. I could take the negative 5 times the 7. Negative 5 times 7 is negative 35. Then I can multiply this x to the 5th times this x to the negative 2nd. Well, if I add the exponents, that's going to be x to the 3rd. Then if I have this y to the negative 3rd and y to the negative 4th, well, that's y to the negative 7th. And I got that by adding the exponents together. Negative 3 plus negative 4 is negative 7. But this is not the way that I want to leave my answer because this is a negative exponent. So the negative 35 is okay, and that's going to stay negative 35 x to the 3rd. But if I want this exponent here to be a positive exponent, I'm going to have to move it down to the bottom. My final answer is going to look like this. Negative 35x to the 3rd times y to the 7th. Let's move on here. Let's take a look at number 8. I'm going to have to erase some of this work so that I can see what I'm doing here. And so with this one, I'm going to multiply everything together, and I can write this. This is a number in scientific notation by another number in scientific notation. And I don't have to put the parentheses there. I can write this as 3 times 10 to the 4th times 5 times 10 to the 3rd. And so I can multiply the 3 times the 5 together. That gives me 15. And then 10 to the 4th times 10 to the 3rd is 10 to the 7th, because I'm adding the like base. I'm adding the exponents because I'm multiplying like bases here. The problem with this is it's a correct answer, but it's not in scientific notation. The decimal is here, but I want the decimal to be between the 1 and the 5. So I'm going to write it as 1.5, not times 10 to the 7th. 10 to the 7th would be, if I started here with the decimal, I'd move it 7 spaces to the right, but I want to start with the decimal here, which means I'm going to have to move it 8 spaces to the right to get it to where it's supposed to be. And so my final answer for number 8 is 1.5 times 10 to the 8th. Let's take a look at one more problem here. Again, scientific notation, except these numbers are small numbers in scientific notation, and I know that because their exponents are negative. So again, I'm going to multiply the 2.5 times 6 together first. That's going to be 15. And then if I multiply the 10 to the negative 3rd times 10 to the negative 5th, that's 10 to the negative 8th. And I did that by adding the exponents together. But again, this is not a number that I don't want to leave it this way because it's not in scientific notation. This decimal is here, and I would move it 8 spaces to the left. But I don't want the decimal here. I want the decimal here. I want to write it as 1.5 times 10 to a power. But if it was here, it would be 8 spaces to the left. Here, I've already moved it one of those spaces, so I have to move it 7 more spaces to get it to where I need it to be. And that's going to be 1.5 times 10 to the negative 7th. This is the kind of thing that we're doing on our homework assignment for tonight. And hopefully we'll do well with that, and we'll go over questions that you have tomorrow in class.